Hi, I'm Praja, and my health project is on exercise and the immune system. We're going to be looking at long-term and short-term effects of exercise on the immune system. And the popular belief is that exercise helps the immune system, but that is not necessarily true, specifically for the short-term acute effects. Personal rationale, the reason why I chose this project is because I'm a runner and I exercise regularly, and I would like to know, as personal information, changes that I undergo in my body on my immune system. Also, I want to be a physiotherapist when I grow up, and it would be great to share this information with the athletes I'll be working with, or with my friends, my athlete friends. We're going to be looking at acute immune response to endurance exercise right now, and a study by Neiman on 62 experienced marathon runners, age about 40, each with about 21 plus or minus one marathon of experience. Also in this study, there will be 10 non-athletic subjects, which during the experiment they will be not doing any exercise. They will just be there for control for diurnal changes. These runners, they ran for 2.5 to 3 hours during the experiment, and after the exercise, blood samples were taken. Also, blood samples were taken prior to exercise, and they were taken up to a day after the exercise. And what was found is that granulocyte and monocyte numbers grew significantly, but the decrease in lymphocyte, specifically T cells, natural killer cells, and B cells was seen. And that is very important because T cells and B cells, they act to non-specific antigens, foreign antigens from foreign pathogens. They engulf and destroy them, while natural killer cells, they protect the body from infected own body cells, and they destroy them. It was also found that glucocorticoid numbers were increased within the blood, more specifically cortisol, and cortisol is known to suppress the immune system. Also, it was found that mucociliary function didn't work as properly. The cilia didn't beat as often, and some of them didn't beat at all, up to a few days after the exercise, meaning that debris or foreign substances entering the body through the nose wouldn't be expelled as quick. And all these reasons together is probably why many endurance athletes get upper respiratory tract infections. Now we're going to be looking at acute immune response to anaerobic exercise. And Mom did a study on eccentric exercises on 12 men aged 22 to 35, which were all regular exercisers. And they all performed a warm-up followed by 5 sets of 30 walking steps. And these walking steps would be more like lunges, where the front leg would be bent at 90 degrees and then the back leg would be touching the ground, 30 of those, 15 each leg. And this was in order to induce soreness and inflammation within the muscle belly. And blood samples were collected prior to exercise, 6 hours, 24 hours, and 48 hours after as well. It was found that post-exercise leukocytosis was present, which means that the number of leukocytes increased, and this is known to cause liver damage, and it's present during muscle damage, but it's not of significant concern because there's not enough of them and not for long enough to cause any bad damage. It was also found that lymphocyte numbers, B cells and T cells, again, were suppressed, as well as cortisol was present, more cortisol than usual, because of the stress put on the body. The difference between an endurance exercise and anaerobic is that mucociliary function stayed the same in anaerobic exercise, which is the reason why anaerobic exercise probably doesn't induce any upper respiratory tract problems. Now, the long-term effects of exercise on the immune system. There's a study done by Neiman on 32 sedentary elderly women aged 67 to 85 years who were randomized into 2 groups, one walking and one calisthenic group. Also in this study, there was 12 highly conditioned elderly women included who were currently active in competitions, and baseline blood samples were taken from all these women, and it was seen that the conditioned elderly women had 1.5 times as much natural killer cell and T cell function compared to sedentary counterparts, and then the experiment was taken, where the conditioned elderly women continued doing what they were doing during their daily lives, and the walking group would train 5 times a week, and each time they would walk at a brisk pace for 30 to 40 minutes, and the calisthenic group would be engaged in range of motion exercises and flexibility exercises. After the study, blood samples were taken again, and it was found that there was no significant difference in natural killer cell and T cell function. The conditioned elderly women were still 1.5 times more efficient than the sedentary counterparts, which shows that these changes only occur after a lifelong, exercise, not just in 12 weeks. But the walking group did improve their VO2 max by 12%, while the calisthenic group didn't experience any changes. Now, preventions from getting any infections. Peters did a study with vitamin C supplementation on 29 ultramarathoners, and these ultramarathoners would be split into 2 groups, one control and one experimental group. And 4 to 6 weeks prior to the race, to their experiment, the subjects met in a lab where all agreed to avoid usage of large dose of vitamin and mineral supplementation. And this means that they wouldn't go above 100% of daily value. They also agreed on not taking any anti-inflammatories a day before and during the event. Then after this, the experimental group was to meet again a week prior to the race event, and the control group, and they were given, the experimental group was given vitamin C supplementation, 500 milligrams dosage of pills, and they would have to take 3 doses a day, while the control group would be given placebo pills. Then during the exercise itself, the event, the experimental runners, they would be given 500 milliliters of water every 30 minutes, while the control of water and vitamin C every 30 minutes, while the control group would only be given water every 30 minutes. After the event, blood samples were taken, and it was seen that blood samples stayed approximately the same between the 2 groups, but the big difference was seen that compared to the control group, the experimental runners experienced only 15% upper respiratory tract problems, as opposed to 40.4 in the control group. Another supplementation from another study is carbohydrates, and carbohydrates also help with the immune system by suppressing cortisol, which is by stopping cortisol production, which is known to suppress the immune system. But it only works in events an hour or longer. It should be taken every hour, depends how long the exercise is. Now, the conclusion is that a acute response in exercise results in immune system suppression, no matter if it's an aerobic or an anaerobic exercise. And the long-term response to exercise results in an elevated immune system activity compared to sedentary counterparts. And also that vitamin C supplementation is good for avoiding any infections and events taking longer than 5 hours. Less than 5 hours vitamin C has not been shown to be too effective. And carbohydrates should be taken otherwise if events are shorter than 5 hours, but higher than 1 hour. Now, limitations and the further study. Limitations that many studies involve only males and few are females. Also that Google Scholar was the only search engine used. Also, further research. The further research should be done around dosages of carbohydrates and what's the best dosage of carbohydrates ingestion. And also, more research should be done on women. Now, to answer your research question, how does exercise affect the immune system, either short term or long term? Well, there's a negative influence on the immune system in the short term, while long term, the immune system adapts to being suppressed and gets stronger as a result. Thank you.